Good morning to everyone. In this video, we are going to know about semiconductor and electronics. What is semiconductor? What is electronics? And before that, we have to clear this chapter. That is a term, semiconductor and electronics. We know very well about physics. I think I am going to mention the word of physics. The word of physics deals about the properties of matter. Am I right? Yes. So matter is nothing but the object. It's a state of material otherwise. So the state of material can be classified into number of three categories. Commonly we know first one is conductor. Second one is insulator. Am I right? What is conductor? The conductor consists the plenty number of free electrons. And also here the electrons are loosely bounded. But in the insulator, the quite controversy of conductor. In the insulator, the number of electrons are tightly bounded. Am I right? Yes, sir. So in the insulator, there is no free electron to carry over the charge from one place to another. Okay, sir. But we are discussing about semiconductor. What is the relation between these two? Once again, I am going to give one more information regarding the conductor and the insulator. So these two materials are classified by the resistivity of these two materials. So somewhat resistivity is having conductor and then insulator. So in the basis of resistivity, conductor and then insulator, there is somewhat in between some resistive materials there. That one is having semiconductor. So hereafter you can easily define what is semiconductor. The resistivity lies between conductor and then insulator is called a semiconductor. Am I right? Yes. And then one more thing, one more good, fabulous, interesting factor. Sir, the resistivity between conductor and then semiconductor, it gives a superconductor. And then one more interesting factor is the resistivity lies between semiconductor and then insulator as a dielectric. We know very well about the dielectric. We learned in first unit electrostatics. So there is the presence of electric dipole, that should be called as dielectric. There is the presence of tightly bonded electrons, that is called insulator. All the dielectrics are insulated, but all the insulators are not dielectrics. Listen. Now we are going to focus on semiconductor. What is semiconductor and what is electronics? The usage of semiconductor gives a sophisticated and then usage of a number of devices. So number of sophisticated devices are given by this material alone, semiconductor. Familiarly, silicon and then germanium. These two materials are the familiar in semiconductors. So I am going to use this two material and make a lot of applications by making certain electrical circuits. Okay. And before that, electronics. What is electronics? Have you ever seen in electronics by the practical? Yes, sir. We are obviously seeing electronics in a many manner. I will give an example. In your house or wherever you go, you can see the tube lights. In your house, there are two different types of tube lights are available. Nowadays, oftenly we are using LED lights. Am I right? So LED tube lights are electronic devices. And then, sir, in my house, if I am supposed to switch on the key, that is a tube light key switch, immediately the light does not glow, sir. After some times, after some flickering, after some blinking of light, then only it will glow, sir. That type of tube light is called electrical tube light. Once you switch on the light, the light will be immediately glow. That is electronic devices. So this is the main difference you are all often seeing in and around of everywhere. So we should know about electronics. Electronics has become a part of life in day to day. We are living a sophisticated life in society and everywhere, in our house, in our world, in our environment. This sophisticated brings only the usage of semiconductor and electronics. For example, we are often using mobile phones, music systems, TVs, washing machines, and etc. We are all dependent of electronics. What is your phone number? Sorry sir, just wait. I will go through my phone and then I will give my number. So the memory also we have saved in this electronic devices. Without mobile phone we can't nothing. Everyone is in there. So electronics is everywhere in filled our nature and then society, universe, world. So electronics, if you want to know the meaning and then depth of electronics, you should know the evolution of electronics. Sir, in the middle of 17th and 18th century, the electronics began with vacuum tubes, and later onwards, some of the inventions produced by the scientists like a diode, triode, that is a transistors, and some of the microchips used by the silicon and the germanium, that should be called as integrated circuits, ICs. These are all the familiar electronic components. But sir, when the electronics get the maximum peak of development at the Second World War, and this period, the electronics get the most revolution by the Charles Babbage. He is invented the computer. I think, yes, that was right. We know very well about the computers of generation. That is generation of computer. We are living in the 5th generation and the 6th generation of computer. So the Charles Babbage invented the computer. Its size is a very macro one. It has a maximum size. So first generation of computer is made by vacuum tubes. And then second generation of computer is made by transistor, that is triode. And then third generation of computer is made by integrated circuit, IC. And then fourth generation of computer, it is made by microprocessor. And then fifth generation of computer, we are now using large scale integrated circuit. That is a human android we are using, and the number of platforms of OS, operating systems. These are all the generation of computers. So once the first generation has the maximum size in a macro size, nowadays we are using the mobile phones within our palm. So number of devices, number of computers is available in the small tiny sizes. That is the very great revolution of computer. Okay sir. Now in this session we are going to know about the semiconductors and electronics. what is the relation between electronics and physics? Electronics and physics. Sir, electronics is a branch of physics incorporated towards the behavior and making of electrical and electronic circuits. And also, it despite of performing the motions and behaviors of electrons and holes in semiconductor. In semiconductor, there are two types of charges. One is electron and another one is holes. For the main purpose of studying electronics through the physics, the behaviors of electrons and then holes, the motion of electrons and then holes, that is the main chapter we are going to analyze. What is the performance of electron? What is the performance of holes in semiconductor through the physics? That's why we are using the tool of electronics. So, electronics, it has the plenty number of variety of electrical circuits available. So, in every electronic and electric circuits, it consists of two major components. One is passive components. Another one is active components. The passive components are, we already learned in our previous classes. One is capacitor, and the second one is resistor, and the third one is inductor. These are all the passive components, and then very important role for the purpose of communication and then simplifying our life and making a sophisticated life. So first one is diode, and then triode is nothing but transistor, and then integrated circuits, ICs. These are all the components are using in active. So in this session we are going to know the working and then phenomenon of diode, transistor and then integrated circuits. And before that, we should know the energy levels and energy bands of semiconductor. What is energy level? What is the energy band in semiconductor? And before that, we have to know the basic information regarding the matters. What is matter? Sir, the matter is nothing but the object. In an object, there are maximum number of moles or molecules are consistent. Each molecule consists of large number of atoms. Now, I am going to take as a single atom, that is an isolated atom. So, this one is the isolated atom. In this atom, in a central portion, the nucleus is presented. Am I right? So, the electrons are revolving the nucleus in a circular orbit, only the permitted level. Am I right? Okay. So, this statement is given by the Bohr, Niels Bohr. According to the Niels Bohr statement, sir, in the center of the nucleus, in the first orbit, there are 2 electrons are available here, and then one more is here. And then third orbit, there is a 8 number of electrons are available. How? This will be identified by the formula of 2n square. Where n is the principal quantum number, you are using the value of 1, 2, 3, 4. So first orbit, 2 of 1 the whole square equal to 2 number of electrons in the first orbit. And then 2 of 2 the whole square is equal to 8. 2 of 3 the whole square equal to 18. So in every orbit, there are a number of electrons are revolving around the nucleus. Now I am going to consider the outermost orbit of the nucleus. The outermost orbit of the nucleus. Now let me consider, this is the nucleus. There are plenty number of orbits are available. Plenty number of orbits are available. Now I am going to consider the last, that is the outermost orbit of the nucleus, that is atom. So first orbit 2, 8, 18 and so on. So the electrons are occupied in the first orbital. There is the 2 number of electrons. It is fully filled. So this is the 2 places only available. 2 electrons is placed. So these 2 electrons are occupied in the first orbit. And then second orbit, there are 8 electrons are occupied. So there is no empty space, sir. There is no electrons are moving position, sir. 1, 2, 3, 4, 5, 6, 7 and then one more, 8. So the electrons are completely occupied the orbit. That should be called as the core electron. Core electron. When the orbits are increasing, now I am going to focus in the outermost orbit of the atom, that is isolated atom. Here, for example, I am going to take it as the 32 places, that is the 32 electrons are, it should be complete this orbit. But unfortunately, in the outermost orbit, there are only 25 electrons are present. Remaining 7 electrons are not placed in the orbit. So, in this condition, the 25 electrons can be moved in everywhere because the places are empty. Am I right? So, electrons will be revolving in a free manner. So, that should be called as, this type of levels are called valency band. Valency band. Valency band. So, these types of electrons are called valency electron. In outermost orbit, there are a free number of electrons are called valency band or valency band of electron. So, by using this information, sir, actually in solids there are millions solids, sir, that is atoms are combined together. Now I am going to consider only the single isolated atom. There are plenty number of atoms, means you are getting the maximum or number of valency electrons. Am I right? These valency electrons are going to somewhere, that is some band. So this free electron, that is the valency electron, can jump into conduction band. Conduction band. So these types of electrons are called conduction electrons. Conduction electrons. So when the electrons free in the valence band, that is outermost orbit, these electrons can jump from one place to another place. That band, that place is called conduction band. That type of electrons are called conduction electron. Using this information, I am going to give you a fabulous, interesting factor. In a previous time, I insisted to you, there are 2 types. There are 3 types of materials, that is a state of solids available. One is conductor, and then second one is insulator, in between is resistor, that is a semiconductor. These 3 materials are classified by the regarding resistivity. Now I am going to give you one more information. These 3 types of materials are classified by the resistivity, means I am going to arrange this one by one regarding the resistive matter. First one, classification of material. And before that, sir, there are plenty number of free electrons. That should be called as valency band. That is the outermost orbits are having the free electrons. That is a valency band of electron. And then these electrons, these free electrons jumps into conduction band. Am I right? Conduction band. So here there are plenty number of electrons are available. For your kind information, in a valency band, the electrons may be fully occupied or partially occupied. But in a conduction band, the electrons are fully or completely filled, not in the form of partially, but it may be in the form of empty condition. The conduction band may be empty or fully filled. but valency band is fully filled or partially filled. Sir, the valency band of electrons moves to the conduction band. There is some in between some gap is available. This gap is called forbidden gap. Forbidden gap. It has certain amount of energy, so I am going to indicate as the E suffix G. Forbidden gap energy. In the valency band, EV. That is the energy in valency band. EC, conduction band energy, EC. I am giving a formula. The forbidden gap energy can be calculated. Eg is equal to EC minus of EV. The conduction band energy and then minus of valency band energy. By using this information, I am going to classify the three materials. One is insulator. One is insulator. So, easily defined, sir. In an insulator, the conduction band and then valency band, it is separated by the gap. That should be called as forbidden gap. That should be called as forbidden gap. Forbidden gap. So this gap is called forbidden gap, EG. Listen, this is the valency band electron and this one is the conduction band. Here there are plenty number of free electrons are available. The electrons can jump from valency band to conduction band. But in this situation, the electrons cannot move from the valency to conduction band because there is in between certain forbidden gap. Forbidden means it's resistive offer. It gives a most opposing force. So the electrons cannot swim. The electrons cannot move from here to there. It gives a maximum resistive force. So the electrons cannot move from valency band to conduction band. Sir, let me give certain temperature or certain electric field, sir. Even though the electrons are cannot able to move from valency band to conduction band, that much of energy is not apt for this insulator. So this insulator having the resistivity in the range of 10 power of plus 9 to 10 power of plus 11 ohm meter. And the energy value of forbidden gap is 6 electron volt. Okay, students? So in the insulator, there is a gap between conduction band and then valency band. The forbidden gap energy value is maximum. So the electrons cannot move from valency to conduction band. And the next one, insulator. Next one, insulator. Next one, insulator. Sorry, next one, conductor. Sir, let me consider the conductor. Here, sir, the separation between the conduction band and then valency band is compressibly negligible. So there is no forbidden gap energy. Sir, this one is conduction band level and then this one is valency band level. So in between there is no forbidden gap energy. Here the electrons can easily move from valency band to conduction band. Am I right? Because of the forbidden gap energy is too low. So if you are not supposed to give any external electric field and then temperature, the electrons is spontaneously move from valency band to conduction band. This is a conductor. And then the resistivity range value is between 10 power of minus 2 to 10 power of minus 8 ohm meter. And then next we move on to semiconductor. I already insisted to what is semiconductor. The resistivity lies between conductor and then insulator. Am I right? Yeah. Now semiconductor. Semiconductor. So the valency band and then conduction band is separated by a small distance. Separated by a small distance, VB and then CB, conduction band. Here, the electrons can be moved from valency band to conduction band through the forbidden gap energy. In the semiconductor, the forbidden gap energy is slightly compared to less of insulator. Here, 3 electron volt. Sir, what is electron volt? Why you are often using electron volt? The energy level of revolving or orbiting the electron, it should be measured in terms of electron volt alone. So, the forbidden gap energy of the semiconductor is 3 electron volt. If you are supposed to give certain energy to the valence band electron, that is a free electron, like a temperature or electric field, it can easily move from the valency band to conduction band through the forbidden gap. Am I right? Yeah. Sir, when the temperature increases, the movement of electrons growth will be increases, because we know very well temperature is inversely proportional to resistance. If the temperature increases, the resistance will be decreases. So the resistance will be decreases in the forbidden gap energy. It gives the minimum moment of opposing force. The electrons move from easily valency band to conduction band. This is the main controversy between conductor and then in semiconductor. So this is very useful for living in our sophisticated life. So these 3 materials, these 3 states, insulators, semiconductors and then conductors. And before that, the range of semiconductor of resistivity is 10 power of minus 5 to 10 power of plus 6 ohm meter. Okay. So, what are all the materials using in semiconductor? I already insisted you 2 materials are commonly used. That one is a familiar material. That one is silicon and germanium. Silicon and germanium. For the silicon, the forbidden gap energy value is 1.1 electron volt. And then, if suppose this semiconductor is like a germanium, if you are supposed to use a germanium, the forbidden gap energy is 0.7 electron volt. 0.7 electron volt. Very important parameter. By using this information, we are going to make a fabulous diode and then interesting triodes and then integrated circuits. And before that, we should know the semiconductor properties and then types.